This is the second in a series of videos where we revisit computers we have built in the past to see how they are doing, and also to see if there's anything we would change if we were building such a machine again. This here is one of our protein folder computers. At one point in time, I built 3 computers specifically to do protein folding. These computers have an AMD A10 7870K processor. This processor has integrated graphics, or Radeon R7. It has a total of 12 compute cores, 4 processing cores and 8 graphics cores. The processor has a clock speed of 3.9 GHz, but can boost up to 4.1 GHz. The processor itself was launched in May 2015, fitting into an F2 Plus socket. The TDP or thermal design power of this processor is 95 watts. This is its power consumption under a maximum theoretical load. The higher this number, the greater amount of heat that needs to be dissipated from the case. For this particular processor, hardware virtualization is available. You will see at the top of the case here are the 2 SIM cards. These are DDR3 2400, CL11, that's the CAS latency. They have a heat spreader. These fit quite neatly into the top of the board between the processor and the ATX power connector. The operating system on this computer is Windows 10 Pro and is running on this small 256GB mSATA SSD connected into this port here. When the motherboard arrived, it had a Wi-Fi card into this port, and I removed the Wi-Fi card and replaced it with this mSATA SSD, which sits flush on the board and saves any cabling for SSDs or hard disks. The motherboard itself has 6 SATA ports, which would have made it ideal for building a NAS. The motherboard itself is an ASRock FM2A88X ITX board, supporting PCI Express 3, and it has gigabit LAN. The power supply at the top here was the smallest power supply I was able to obtain at the time. This is a 300 watt Silverstone PSU in an SFX format, an 80 plus bronze. This 300 watt power supply was needed to supply power to this power hungry CPU. And the cooling on this system is done using a Noctua 120mm fan sitting at the back. In order to monitor the temperature of the processor, I had enabled a small external power monitor unit at the front here. This has a thermal probe which sits into the heatsink of the processor to let us know what temperature it's currently sitting at, because at the time I was concerned that cooling may not be sufficient, but as it turned out, the cooling was quite adequate. As you can see, the power supply at the back here does stick out from the side of the case. So if I were to build these again, I would go for a smaller power supply. Perhaps an HTPlex 500 watt power supply, which would be more than adequate to power this and still sit quite neatly in the frame itself. The frame, of course, is 10mm maker beam. At the front of the case, we have the main panel. This particular motherboard could support 3 monitors, an HDMI, a VGA and a DVI monitor. It also has quite an expansive audio section here, where it also supports an optical port. This is a SPDIF, that's a Sony Philips digital interface format output port, carrying 2 channels of audio. As this machine was designed specifically for protein folding, none of these facilities were actually used, and all we had in the HDMI port was one of these. This is an HDMI plug which emulates there being an HDMI monitor plugged into this socket, which effectively makes the machine headless, so any software that insists on a monitor being plugged in would be convinced that there was actually one here just by having this plug in place. While I am no longer doing protein folding on my computers, I'm currently using these 3 computers for web servers, which is a task they perform quite adequately. Of the 3 machines I have like this, I have 2 running Windows 10 Pro and 1 running Linux Mint. They are no longer top-of-the-range computers, as the memory is DDR3 2400, and the processor is nearly 10 years old now. However, they are still quite adequate to do normal processing tasks, and I see no point of retiring them just yet. When it comes time to actually retire these machines, I will of course recycle all the Maker Beam struts, the fan, the power switch, and possibly the power supply. Each of the components running in this computer is quite capable of running 24/7, and at the height of my protein folding, these machines were running for months at a time. As I referenced earlier, if I were to build a machine like this again, I would go for a power supply which was smaller and also modular. The problem with these power supplies which are not modular is you get a great many cables you don't actually require. For example, cables for floppy disks, cables for SATA ports, and other cables for GPUs, which in this case are not required. But all in all, this machine has been very robust and very reliable, and I will probably continue to use this machine for some years yet. The processor itself is not capable currently of supporting Windows 11, so when the time comes when Windows 10 is retired and is no longer supported, I'll probably make all 3 machines running on Linux Mint. However, that's it for today. Thank you for watching.